Welcome, guys. Thanks for coming in. If you guys are already here, looks like Scotland and Kiara. Glad to have you guys here. I am just waiting for. Oh, actually, might be done. I was creating the PDF version of the book so I could pull it up on the screen, and I was waiting for that to finish downloading. So that's why I'm a few seconds, a minute late. But it's good to have you guys here. Before we get into our next section of soils, just want to say welcome to our science subject, our science class today. I know it's funny to be at home and to be online doing school, but right now we have our science class. So for those that are joining live, it's awesome to have you here joining our science lesson. I'm glad to be interacting with you and talking with you all. And then those that are watching the replay of this, I hope you enjoy learning about what we're going to cover today. So let's start off by reviewing what we read last time. Okay, what did we talk about last time? We talked about soil, right? That's what we're covering. We talked about some things. We talked about the four main components of soil. Can you guys remember what those are? Put those in the chat if you can remember what the four main components of soil are. Glad to have Caden here. Glad to have you guys here. It's awesome. What are the four main components of soil that we covered last time? Well, the majority of soil, about 45%, is rock material or sediment, as we continue to learn as we read through those pages. And then there was a very important part that contained a lot of the nutrients for soil. Do you remember what that was called? It was called humus, right? Humus is about 5% of what makes up soil, and it contains all the nutrients. So not a lot, but a very important part. And the rest, about 25% for the last two parts, is 25% each, is water and air. I know some of you guys knew that, so good job. That was awesome. We talked about how soil is formed, and a big part of it is weathering and erosion. Rocks will get weathered through wind and water, and then erosion takes place and carries those, carries what is weathered to different places. And it takes over, I think it was, 2,000 years, or how long did it take for soil to form? It was a very long time. I want to say 2,000 years to get about an inch of soil, but let's double check that, all right? Maybe you guys can remember better than I can. Good job, Caden. Water, air, and you put humans, but it's humus. Humus. If you know what hummus is, it looks kind of like hummus, except for it only has one M instead of two M's. I'm trying to remember. Okay, so it takes 1,000 years for just an inch of soil to form. So I was over a little bit, 1,000 years. That is a long time, right? And I hope you guys enjoyed doing your pages 2 through 9 assignments. So let's jump into pages 10 through 17. All right. I'll pull it up on the screen. Yeah, that's right, Caden. Air. Rock, water, air, and humus. Okay. So let's start here on page 10. If you have your book, I'd grab your book. You can, you can obviously look on the screen and follow along, but sometimes it's nice to have a hard copy to hold and to read. So let's compare and contrast this building reading skills right here on page 10. I'm just flipping to my hard copy as well, so I'm right there with you. Okay. All right. Build reading skills. Compare and contrast. To compare objects or events is to notice how they are similar. To contrast objects or events is to notice how they are different. And so we can compare and contrast a lot of things, right? We can compare and contrast one person to another. We can compare and contrast, this school year compared to last year, right? And then we're going to compare and contrast different types of soil. Because if you look to the next page, if you have your hard copy, we are learning how soils are alike by comparing them, and then we're going to learn how soils are different by contrasting them. So as we read this section, try to identify similarities and differences among the layers found in most soils. Okay? So here's some tips about how to compare and contrast. Follow these guidelines for comparing and contrasting. Choose two related objects or events. To compare them, ask, how are they alike? What is true about both of them? To contrast them, ask, how are they different? What is true about one that is not true about the other? And then here's a Venn diagram that you can use and draw to help you compare and contrast. You have two circles and they're overlapping in the middle, and you have one thing, or A on one side and B on the other, and those are the contrasting points of how they're different. And in the middle, you can put the things that how they are similar. Nice, Scotland's got her soil book. So Caden's put in the core vocabulary. I don't have that. That's still the vocabulary from our lesson yesterday. But there are questions. I think there are 4, maybe 5 questions that I have ready for you guys today. Looks like Elena has come in, right? Welcome. Yep, there you go. So that hint is in line with today's lesson, right? I don't have the core vocabulary up, so sorry about that. But I do have some questions, right? 5 questions and 5 hints for you. Okay, all right, guys. I'm glad you guys were able to say hi to one another. But right now, it's time to focus and learn about soils, okay? So please remember to keep chat focused on what we are talking about. And then I can give you guys a few minutes to talk to each other after the lesson, all right? If you guys show up early to the lesson, you can chat with one another. And if you stay late after the lesson, you can chat with one another. But during this lesson, we got to stay focused, okay? Please. If you guys are not staying focused in the chat, I will time you out so you can't type in chat, okay? So don't do that. Looks like Caden's already getting ready for question 1. Nice, Caden. That is how you utilize chat to stay focused. Okay. So let's look at the next page, all right? So we are learning how soils are alike and different. We are comparing them and contrasting them. So let's make a connection. Different soils have different properties. This soil is dark and rich, right here referring to the picture. And corn plants thrive in it. What are some differences you have noticed among soils? What might account for these differences? And so I know we haven't really talked about soils a whole lot. We know what soils are made up of, but we haven't talked about how they are different or what makes them unique or special. But try to answer these questions right here. So I don't have hints for these. These are just kind of guess or just educated guess. What are differences you have noticed among soils? So when you're walking outside, what are differences that you notice among soils? And then think, what might account for these differences? And if you don't have an answer and you can't type an answer in the chat, that's totally fine. Just think of those questions to yourself, and those will help you be prepared to learn as we continue to read. Okay, so let's go to page 12 and start reading. Okay, so right here. Layers of soil. So let's follow along. Soil typically forms in layers called soil horizons, which lie on top of one another, like the layers of a cake. So you can think of layers of a cake as soil horizons. Most soils have 3 main layers. Most soils have 3 main layers that are composed of different materials that contain varying amounts of humus. Together, all the layers in a soil are known as the soil profile. So make sure you're paying attention to this. You will have an assignment that is based off of what we are reading and the picture to the right as well. And then you'll also be tested on these things, okay? So make sure you're focusing and paying attention. That's right. Some soils are dry. Good job, Kiera. That is true. The top layer of soil, also called the A horizon, is called topsoil. Topsoil is a loose, dark mixture of rock particles, minerals, and humus. Most plant roots grow in topsoil, and animals and other organisms live in topsoil as well. Beneath the topsoil lies the B horizon, or subsoil. Subsoil is typically lighter in color than topsoil and contains larger sediment pieces and much less humus. Do you guys remember what sediment is? Sediment is the rock materials or rock minerals, right? That makes up most, about 50% of soil. So that is in the B horizon, the subsoil. Rainwater carries clay and minerals from the topsoil down to the subsoil. Although deep plant roots may push down into the subsoil, this layer does not contain nearly as much life as topsoil does. All right, the C horizon, located under the subsoil. So we're talking about this. If you look at the picture on the right, we're looking at the C horizon. So the C horizon contains little or no humus and no animals or plant roots. It is composed mostly of large pieces of rock. This lowest layer is sometimes called parent material because it generally contains the material from the soil above it formed. Sorry, I don't think I read that very good. The lowest layer is sometimes called the parent material because it generally contains the material from which the soil above it formed, right? The C horizon rests on the foundation of bedrock, the solid rock of Earth's surface. To the very bottom right here is the bedrock. Yeah, don't spam random letters, symbols, or stuff like that. Yeah, then things are gonna. So you're good. No worries. Glad you said sorry though. Okay, so we're going to continue to read page 13, and wait 1 second. Sorry, making sure I have a good question. Okay, so for page 12, we have 2 questions, all right? Referring to the word horizon, let's make a connection, all right? So what do we usually mean by the word horizon? When someone says, look out to the horizon, what are they referring to? That's question 1. Looks like Scotland already put the questions, or Caden put question 1, and Scotland put hint 1. And then Caden put question 2. So see if you could answer the question 1. What do we usually mean by the word horizon? And then we'll have question 2, which is, what direction does a soil horizon go? Anybody can answer those questions? So when someone says look out to the horizon, what are they saying? If we were to look out to the horizon right now, what does that mean? It means the earth and the sky, right? That's what we see. When we look out to the horizon, we can see where the earth is, and then above is the sky. That's what we're usually referring to about horizon. And now we're learning about soil horizons. And for question number 2, it says, what direction does a soil horizon go? You can refer to this picture on page 12. The soil horizon goes side to side, right? Okay, let's continue. Let's learn about some properties of soil. Okay, so soils in different places can have different amounts and kinds of rock pieces and other materials. The materials that make up a soil give the soil unique properties. Color is a property of soil that is usually determined by its mineral content. Iron minerals provide the greatest variety of pigments or coloring in soils. Red, yellow, and reddish-brown soils all contain different iron minerals. White or gray soils, on the other hand, contain salts or minerals that have calcium. Black or dark brown soils are rich in humus. Another property of soil is the size of its sediment particles or grains. Sediment is classified as sand, silt, or clay based on particle size. Sand particles, the largest of the three, may be about 1 to 2 millimeters across, about the same sizes as grain of table silt. Oops, sorry, didn't mean to click that. Or click that. We're good. Back. Okay, good. We're good. Silt particles are smaller than sand and look and feel like baking flour. The smallest grains in soil are clay. Silt and clay particles are so tiny that they can be seen only with a magnifier. Whoa. Most soils contain a mix of sand, silt, and clay grains. The different amounts of each particle size give soil its texture or feel. A soil composed mostly of sand has a coarse texture and feels gritty. A soil that contains a great deal of silt has a fine or smooth texture. All right, so if we were to look at this this picture right here, what gives this soil this type of color? Why is this soil this reddish brown color? And then why does this soil look different from this picture? So that's our question 3. What gives this soil its color? Anybody? Come on. Got about 4 or 5 of you guys here. Can one of you guys answer what gives this soil this reddish brown color? Something that this soil doesn't have. The bottom picture. This bottom right picture. I need you guys to start interacting, okay? That's why we're doing these live lessons. If you guys don't want to interact and ask questions and answer questions, I can just start doing recorded lessons. You can just watch them. But I'm trying to create a place for us to interact and for you to answer questions, ask questions. But if we don't get any interaction, then we're just gonna, I'll read and you guys can, try to figure stuff out on your own. I'm here to help you guys. That's why we're doing these live lessons. Good job, Kara, trying. Is it hot? It could be hot soil, but hot doesn't change the color. Nice. Caden's got it. Iron minerals. Thank you so much. That is awesome. That is correct. So it's iron minerals that give soil these different bright colors, right? We read that iron minerals give soil red, yellow, and reddish brown colors. It's through the iron minerals. And so this soil on the bottom, right below that picture, is very brown and kind of like a dull color. Right? And if you read the caption, it says, this light-colored soil contains very few iron minerals, but likely has a lot of calcium minerals. All right. And we learned that soils are composed of sediment particles or grains of different sizes. Sand has large grains, silt has medium-sized grains, and clay has the smallest grains in soil. And so we're going to do an experiment that's going to have us kind of test the soil that we are living around. Okay, let's keep moving. Page 14. Okay, the ability to hold water is another property of soil. So we learned that one property of soil is the size of its grains or minerals. We learned that color is a property of soil. And now we're going to learn another property of soil, which is the ability the soil has to hold water. That's a big property of soil. So water seeps down through the pore spaces between sediment particles. Generally, larger particles such as sand also have larger pore spaces and are more loosely packed together. Water flows through sandy soils very rapidly, and they dry out very quickly. Such soils are said to have high permeability. You're going to be tested on this, all right? Permeability, so make sure you're paying attention. Permeability is a measure of how easily water passes through material, okay? So if you were to think about permeability, if I were to give you a piece of wood and pour water on it, do you think water would seep through that wood very quickly? No, but it would get in there, right? It's not like it's concrete where it just would kind of stay on the top layer, or metal. Metal probably be a better example. But then if I were to give you maybe a t-shirt and you were to pour water on a t-shirt, how quickly would that water go through? Go through really quickly. It would start spilling on the ground, and that has a high permeability. So let's continue to read right here with silty soils. Make sure you're following along. Silty soils have a permeability that is between that of sandy soils and clay soils. Water passes through at a moderate rate, and the soil stays moist for some time. As a result, silty soils are described as having good drainage, neither too fast nor too slow. Nice. Caden's getting ready for question 4. I like it. Okay, so let's look at this picture. Water sits on top of tightly packed clay soils rather than draining through it. Clay soils have very low permeability, meaning water can't easily pass through it. It takes a long time. Clay soils have very low permeability. These tightly packed soils do not allow water to flow easily through them. Clay clumps together and feels sticky when moist, so water stays in the soil or sits on top of it instead of draining through it. Clay soils stay wet for a very long time. Okay, let's reference this photo really quick and read the caption below it. It says, water flows easily through sandy soil and the soil quickly dries up. Sandy soil has high permeability. What kind of soil do you think that we live around in this high desert? Do you think it's clay soils, sandy soils, or silty soils? All right, that's just a question I just really thought of, so there's no hint. Let's see what you guys say. What kind of soil do you think we live around in high desert? Let's go on to page 15. All right, so the ability to support plant growth is still another property of soils. So the ability to support plant growth, we've learned about color, the size of the particles, the ability to have water pass through them, or the permeability, and now the ability to support plant growth is another property of soil. Soils that support the health and growth of plants are described as rich or fertile. Some soils are better able than others to provide the water, nutrients, and physical conditions that plants need to thrive. The best soil for most plants is a blend of sand, silt, and clay, along with large amounts of humus. Looks like you're trying to answer question 4, possibly, Caden, saying it absorb it. So what are some properties that make loam so fertile and make it absorb it? I'm not totally for sure if I understand what you're saying. Make sure you double check what you're typing. It make it absorb it. About to learn about loam though right here. So most soils found on farms and in gardens are, sorry, I skipped a sentence. So we learned that the best soil for plants is a blend of sand, silt, and clay, along with large amounts of humus. This type of soil is called loam. So most soils found on farms and in gardens are loams. So loam is a blend of sand, silt, and clay along with large amounts of humus. Now let's learn why that is so important for it. Nice. Katie, are you guessing what kind of soil we have around us? Sandy soil? I think you're probably right. All right, so loam is fertile because it provides the right amounts of water and nutrients to plants. All plants require water to live and grow, and the mixture of particle sizes in loam makes the soil well drained. Right? Remember the particle sizes, clay, sand, and silt? That is, water does not move downward too quickly beyond the reach of plant. So loam isn't high permeability, meaning water passes through very quickly. It isn't low permeability, meaning it sits on top like clay. It has a medium permeability, meaning it can move it's well drained, that it has time for the water to soak up in the soil. So that is, water does not move downward too quickly beyond the reach of plant roots, nor does it remain in place to soak or drown the roots. Plants also need nutrients to develop and grow, and loam is especially rich in nutrients. The humus in loam supplies many essential plant nutrients, and certain minerals in loam are also important plant materials. So I hope you guys understood what loam is, and if you have questions, let me know. You will get tested on loam. So yep, just make sure you remember. Are you guessing sandy soil for what kind of soil we live around Scotland? All right, so our question is, what are some properties that make loam so fertile? Nice, good job, Scotland. Yeah, we live in a high desert, and we have, a lot of plant life around us that don't require a high amount of, water or nutrients, right? That's why it's the desert, because water doesn't thrive here. And we're, kind of in a drought. Okay, so question 4 is, what are some properties that make loam so fertile? See if you can answer that question. And then we have we have 2 more pages left, so 1 more section left. Going to learn about soils in different places. So I'll give you about a minute to answer that question, and then we'll move on. Okay, we learned that loam didn't have high or low permeability, but it had about a medium permeability, because it had different grains or particles it had a mixture of clay, sand, and silt, which allowed water to travel through it at a good rate so that the plants could, hey Nevea, how's it going? So that plants could soak up the water. And then it also had a lot of nutrients. It had a lot of humus, which contains a lot of nutrients. And so being medium permeability and having lots of nutrients offer loam to be one of the best, if not the best, soil for plant growth. Okay, so soils in different places. All right, many factors, let's follow along right now. Many factors influence the type and thickness of soil found in a particular environment. These factors include the rocks and minerals that provide the soil sediment and the area's climate. The organisms present in the area, for example, an environment with abundant organisms is likely to have fertile topsoil because of all the plant and animal matter that may decompose there. The shape of the land also helps determine an area's soil. For example, soil at the bottom of a hill is typically thicker than soil at the hilltop. Time also plays a role because soils develop and change as time passes. Older soils are generally thicker than younger soils. There are enormous kinds of soil on Earth. Soil scientists have identified more than 20,000 different soils in the United States alone. Wow, that is a lot. One way of classifying soils divides them into groups according to where they're from. All right, so forest soils are usually quite fertile and have a subsoil layer that is high in clay. A layer of dead leaves and other plant matter often covers the fairly thin topsoil in forests. This material, sometimes called leaf litter, helps keep moisture in the soil, provides a home for organisms, and in time becomes humus. So this leaf litter becomes humus at some point. So we're about to read about grassland soils. We just read about forest soils. We're about to read grassland soils and desert soils. And so our question is going to contrast the difference between grassland and forest soils. So question 5, our last question for today, is why do you think desert soils are not fertile the way forest and grassland soils are? So we just read about forest soils. We're about to read grassland soils, and then we'll end with desert soils. And then you'll be ready to answer question 5. So grassland or prairie soils have a thick topsoil layer, rich in humus, which gives the topsoil a dark brown color. As the roots of grasses decompose, they enrich the soil, making it particularly fertile. The roots also hold the soil together and prevent it from eroding. Food crops such as wheat and corn are often grown in fertile grassland soils. And so if I were to make an educated guess, I would say about the Midwest has a lot of grassland soils where a lot of our nation's food crops are grown, right? There's a lot of corn and wheat as you drive, from the East Coast to the West Coast. You can see in the Midwest. All right, our last section. Desert soils that form in desert areas are dry for most of the year and generally support little plant life because the top's horizon contains almost no humus. It is usually light in color. Desert soils often contain a lot of minerals, especially salts. When it does rain, the water collects near the surface and dissolves the salts. The water quickly evaporates, leaving behind a hard crust of salts and other minerals. The effects of wind and light rainfall may also give the soil a stony surface or tightly packed small rocks called desert pavement. Alrighty. So, question 5 is why do you think desert soils are not fertile the way forest and grassland soils are? Looks like, Katie, you're saying it provides the right amounts of water and nutrients to plants. Are you talking about loam? Loam definitely provides the right amounts of water and nutrients to plants. So that's really good if that's what you're referring to. Well done. So let's answer question 5. Question 5 is why do you think desert soils are not fertile the way forest and grassland soils are? What are some differences between those? Contrast, like we talked about at the beginning of this lesson, comparing and contrasting. Let's contrast the difference between desert and grassland and forest soils. No one is answering. All right. Well, so we just read that grassland and forests have a lot of nutrients, and they contain a good, rich topsoil that has color and has a lot of humus. Sorry, there you go, a lot of humus. And the desert soils, the topsoil contains little humus, right? And it's very dry in the desert. These soils don't hold water very well. It kind of dries up the ground instead of enriching the ground. So those are the differences right there. The desert contains little humus and are sometimes, read this caption, desert soils have very little humus and are sometimes capped with a hard salt crust. Unlike right here, grassland soils support the growth of food crops because of their thick, rich topsoil that contains a lot of humus. Okay, well that is our lesson for today. I will allow you guys about 4 minutes to chat with one another if you want, but then I need to get back to the school because I'm going to be helping with math there. So if you guys have questions for me, please let me know. If you guys want to talk with one another, you guys can. We will have to make a change for our open office hours. I think Thursday at noon will still work, but I might have to switch today's, like Tuesdays. Sorry, excuse me. I'm probably have to switch Tuesday to Monday. All right. Yeah, I saw you at school, Skylar, and that was awesome. I've been able to see a few of my students at school now, which has been really cool. And Scotland is one of the few students that is basically on top of all of her schoolwork, all right? So you guys can ask me for help, but if you guys are friends or want help with schoolwork, I would also reference you to Scotland. Yeah, she could help you. So just about 3 more minutes if you guys want to chat. And then, yep, like I said, I gotta get going. Yep, you Scotland. That's right. Make sure you're getting caught up with all of your work. We only have basically a week and a half left of this first quarter, all right? Get caught up with math. See you, Scotland. Have fun. Hey, Nevaeh, how's it going? Just about 2 more minutes, all right? 2 more minutes if you guys have any questions. Let me know. Or if you guys just want to talk to one another, you guys can. Me what? I don't know. What are you referring to? Just 1 more minute if you guys have any questions, and if you don't, it's fine. There you go. Kara's asking Elena if she wants to play Animal Crossing later. Oh, Scotland, I was saying that if people need help with their schoolwork, they can obviously ask me, but you are also on top of all of your schoolwork, and so I said that if some of the students are friends with you, they could ask you, or if they want to become friends with you and ask for help, that you'd be a good resource. So that's what I was saying. I don't know, does Elena want to play Animal Crossing later? Okay, well, that's it, guys. I gotta get ready to go back up to the school because the second session starts soon. Thanks for joining. It's good to talk with you guys. Good to have a good lesson and learn more about soils. We just have one more soil section next week, and then we'll have our soils test. So make sure you're doing the assignments. There's, I'm pretty sure, 2 assignments for this section. So get those done, and I will see you guys hopefully tomorrow. Okay, see ya.